Hello everyone. Today I'm going to be continuing the first chapter on data and statistics, particularly the section number 2 on data and its four subsections. First, elements and variables and observation, skills of measurement, categorical and quantitative data, and finally cross-sectional and time series data. Right. As you know, the first thing that comes to mind is to fix term, to understand concepts and definitions. Data are the facts and figures collected, analyzed, and summarized for presentation and interpretation. And all the data which has been collected in a particular study are referred to as a data set for the study. Now, the table 111 it shows you a data set which contains information for 25 mutual funds that are part of the Morningstar Funds 500 for 2008. Basically, just as an important information about Morningstar. So Morningstar is a company that tracks over 7,000 mutual funds and prepares in-depth analysis of 2,000 of these meaning mutual funds. Basically, their recommendations are followed closely by financial analysts, by individual investors, and so on. First subsection under the data: elements, variables, and observation. What do we mean by an element, by a variable, and even what do you mean by an observation? So elements are the entities on which data are collected. If we go back to the same table 1.1, for the data set in table 1.1, as you can see, each individual mutual fund is called an element. The element names appear in the first column with 25 mutual funds, and the data set contains 25 elements. This is what we mean by an element. Element or individual. They are both terms interchangeable. You can sometimes come across individual, you can sometimes come across even element, but just remember they are the same. A variable is a characteristics of interest for the element. Let's go back to the same table 1.1. The data set here is in table 1.1 and includes the following 5 variables. First variable, which is fund type. The type of mutual fund we've got labeled IA, which stands for international equity. We've got DE, which stands for domestic equity. We have FI, which stands for fixed income. This is the first variable. The second variable, which is net asset value, expressed in dollars. The closing price per share on December 31 2007, basically. And the third variable, which is 5-year average return on percentage, it's the average annual return for the fund over the past 5 years. And the fourth variable, which is the expense ratio in percentage, obviously, it gives us the percentage of assets deduced each fiscal year for fund expenses. And finally, we have morning rank as a fifth variable, which gives us the overall risk-adjusted star rating for each fund, basically. measurements collected on each variable for every element in a study provides the data. And the set of measurements obtained for a particular element is called an observation. Just remember, an observation, right? Referring to the same table 1.1 here, as you can see in front of you, we see that the set of measurements for the first observation, let's say American Intel disk, is international equity 14.35, 30.53, 1.41, and 3 star. So the set of measurements for the observation, for instance, let's choose any random element. Let's say that the fifth one, brown cap small. DE, domestic equity, 35.73 equals for the net asset value, 15.85 goes for the third variable, which is 5 years average return. Then you have 0.53, and finally you've got the Morgan star rank, which is 3 star. Now, about scales of measurement. When it comes to scales of measurement, data collection requires one of the following scales of measurement all the time. It could be nominal scale, ordinal scale, interval scale, or ratio. And the scale of measurement, basically, it determines the amount of information contained in the data, and it indicates the most appropriate data summarization and statistical analysis, right? Let's start with the first, nominal scale. When the data for a particular variable consists, just remember, consists of labels or names used to identify an attribute of the element, the scale of measurement is considered a nominal scale. Nominal name comes from label, right? Just remember. For example, referring to the data on the table 1.1, the same table, we see that the scale of measurement for the fund type variable is nominal because we've got 3 categories. IE, which stands for international equity, FI, fixed income, and finally, they stand for domestic equity. Those are labels and names, which is scale of measurement. Which one? Which is nominal scale, obviously. So these are labels that they're used to identify the category or type of fund. Let's see, in cases where the scale of measurement is nominal, sometimes a numeric code as well as numeric labels may be used. For example, to facilitate data collection and to prepare the data for entry in a computer database, we might use a numeric code by letting 1 denote domestic equity, 2 denote international equity, and 3 denotes fixed income. In this case, the numerical values 1, 2, and 3 identify the category of funds, right? And the scale of measurement is nominal, even though the data appear as numeric values, right? Just remember. Okay. The second scale of measurement is ordinal scale. And the scale of measurement for a variable is called an ordinal scale if the data exhibits the properties of nominal data and the order and classification or rank of the data is meaningful. For example, let's say East Side Automotive, it's a company, right? It sends customers a questionnaire, a survey designed to get data on the quality of its automotive repair service. Each customer provides a repair service rating of, let's say, excellence, good or poor. Because the data here are the labels, excellence, good or poor, the data have the properties of nominal data. In addition, the data can be ranked or ordered or classified with respect to the service quality. Either you've got excellence, good or poor, right? Data recorded as excellent obviously indicates the best service, followed by good and then poor. Therefore, the scale of measurement is ordinal. As another example, note that the Morningstar rank for the data in table 1.1, as you can see, once again, is ordinal data. It provides a rank from 1 to 5 stars based on Morningstar assessments of the fund's risk-adjusted return. Ordinal data can be provided using a numeric code, for example, U-class rank in school. The third scale of measurement, which is interval scale. The scale of measurement for a variable is an interval scale if the data have all the properties of ordinal data and the interval between the values is expressed in terms of a fixed unit of measure. Interval data are always numeric. For example, scholastic aptitude tests, right? It's a test. Scholastic aptitude test scores are a best example of interval scale data. For example, 3 students with scholastic aptitude test, math, and let's say in the subject math scores of 620, 550, and let's say 470. These 3 scores can be ranked or ordered in terms of best performance to poorest performance, from the best performance to the poorest performance. In addition, the differences between scores are meaningful. For instance, students 1 scored 70 points more than student 2, while student 2 scored 80% points more than student 3. And the final type of scale of measurement, which is ratio scale. So the scale of measurement for a variable is a ratio scale if the data have all the properties of interval data and the ratio of 2 values is meaningful. Variables such as distance, let's say height, weight, and time use the ratio scale of measurement. And this scale and this scale of measurement, which is ratio, it requires that a 0 value can be included to indicate that nothing exists for the variable at the 0 point. For example, consider the cost of a car. A 0 value for the cost would indicate that the car has no cost and is free. right? In addition, if we compare the cost of $30,000 for one car to the cost of $15,000 for a second car, the ratio property shows that the first car is 2 times or twice the cost of the second car, which is logical, right? Now, let's move on to the differences between categorical and quantitative data. Basically, data can be always classified as either categorical or quantitative. Categorical, we meaning here qualitative. Quantitative, we meaning numerical, right? Data that can be grouped by specific categories, qualities, are referred to as categorical data, or once again, qualitative data. Categorical data use either the nominal or ordinal scale of measurement. It's quite important to remember this once again. Categorical data use either the nominal or ordinal scale of measurement, whereas data that use numeric values, numbers, metrics, quantitative values, numeric values, to indicate how much or how many are referred to as quantitative data. Quantitative data are obtained using, obviously, either the remaining type scale of measurement, interval, or ratio scale of measurement. Now, the last section under the data, which is cross-sectional and time series data. In brevity, cross-sectional data are data collected at the same and approximately the same point in time, whereas time series data are data collected over several time periods. Please remember, they follow that subscribers. The difference between the two, cross-sectional data are a data collected, which has been collected, gathered, right, at the same or approximately the same point in time. It's an important concept. Whereas time series data are data collected over several time period, right? The data, for instance, in table 1.1 are cross-sectional because they do describe the 5 variables for the 25 mutual funds at the same point in time, right? Remember, at the same point in time. And the time series, once again, are data collected over several periods of time. Here is a graph, as you can see, for example, time series here in figure 1.1. It shows the United States average price per gallon of conventional regular gasoline between 2006 and 2009. Note that higher gasoline prices have tended to occur in the summer months, with the all-time high average of almost $4.05. Yeah, $4.05 per gallon occurring in July 2008. By January 2009, gasoline prices had taken a steep decline to a 3-year low of $1.65 per gallon. Here is some of the examples I've write of graphs on time series. The first on Dow Jones Industrial Average. The second graph is on net describe the net income per for McDonald's, and the last one describes the occupancy rate of South Florida hotels. So thank you. So now here I've come to the end. Thank you for your listening. See you soon.